Henrik Johansson, principal in our Office of the CISO team within AWS Security. As you can tell, are you awake now? Good. As you can tell by the name, I'm based here in Seattle. Before that, I was based in San Francisco, hence the name. And I'm going to talk a little bit about AWS. And first off, how many people here are running cloud workloads today? Any type, not AWS, any type of cloud workloads. Couple more, awesome. So the thing is, I said it, in today's world, with cloud technology, you've literally never had more opportunities to revitalize and optimize your security posture. To know what is going on in your account and to know what's going on in your environment. Doesn't matter if you run, excuse me, doesn't matter if you run Kubernetes, if you run native services, if you run web services, whatever it could be. But the technology that is at your hands that you can use to figure out what's running today is immense. It's never been this easy to figure out exactly what you have. The thing though is that mistakes can be made. You probably read in magazines and whatever, people make mistakes now and then. It could be anything from non-hardened instances, could be non-hardened infrastructure at a large. Someone might have not used Git secrets and posted their keys on GitHub. Could be just regular vulnerabilities coming out all the time. Container image corruption. There's a lot of things that could happen. And we can also have something that leads to. It could be that you lose control of your infrastructure. Now suddenly you're paying for someone else's use of your resources. Could be that they shut down your services or they shut down your infrastructure completely. Or there could be something that they just want to use you as a jump post. I'm not going to ask who has had that happen to them, but that happens all the time. Like, someone will get owned all the time. And all up to us how we secure this and how we prevent this. So what actually matters when it matters? It's visibility. Knowing what you have. And even more, knowing what you have that is not normal. It's knowing that, do we normally run Bitcoin mining in our Asia region? Or is that something that is odd? Should we be running this? Do we normally host this information? Do we normally have these ports open? People often talk about that server under the desk, that a developer, not to diss any developers in here, but they're doing an awesome job. But that server under the desk, or that test equipment, or I'm just going to open up this security group to test a little bit from home. Because my IP is 100% stable and no one would ever change that. And I promised to change it back right after, 2 years ago. And it's knowing that. And the thing is, if you run in a cloud workload today, it doesn't matter which cloud, but if you run in a cloud workload today, there is no way to hide resources. You cannot hide an instance. You cannot hide credentials. They are available through an API call to everyone had permission, of course, to do so. But there is no way to hide that server under the desk. If you don't know about it, you're most likely not doing it right. If you look at, actually, how many people are working in any type of incident response teams or on-call duties? A couple of people, I'm sorry. The thing though is that, I don't know if you can see that, but this is a typical IR lifecycle process. It's circular. It's you basically go from identify, protect, detect, respond, recover, start over again. This goes on all over again, and you can just learn from whatever you did, hopefully, and fix it. So it won't happen again until the next time it happens again. But how do we get this? How do we get that identified? How do we get that visibility into us and knowing what it is that is running? Well, there's multiple ways. Here's the more like traditional analogs. Log parsing, just going through every log you have. Doesn't matter if it's the logs we provide as a cloud provider, or if the logs that you get from Kubernetes, from EKS, or from application logs. One of the most forgotten things in today's world, because we have so much information to our hands, traditional application logs. How many people in here, and I like to ask questions, so I apologize. How many people in here are collecting the actual application logs from the actual system that they're running? Couple. Awesome. It's still only about 40%. There's a lot of things that are being generated from those. The second thing is canaries. Just knowing what you have out there and expecting to be there. I'll do the next poll. How many people run some sort of, like, if you run on us, like Lambda functions, but serverless functions or whatever, that they use that to help with their incident response systems, like automatic remediation, detection, whatever? Anyone? Couple? How many people of you are actually checking that those functions are there all the time? 2? Doesn't matter what you're running. If you're running a Kubernetes cluster, if you're running a serverless function, if you're running a Lambda, just having canaries to verify that we expect this information to be there, but you're actually validating that it's there. This is a really good telltale that something has happened. If you're expecting that there is a function called the XYZ, and you're expecting to have this SHA, like a SHA-256 or whatever it could be, or MD5, of that code base, and suddenly it's different, or suddenly it's not even there, or suddenly you can't even access that account to see that it's there, something happened. Even if it's not malicious, something happened. Someone went in to do a fix or a change on that specific function, but not everywhere else, and they didn't update the source. These are really good information sources that something happened. There's a lot of tools out there. There's a lot of third parties. I mean, we're here because of third parties today. There's a lot of tools out there that will tell you what is going on in your infrastructure. These are all good. They will provide you with a lot of valuable information. Check them out. Staff, more staff, and even more staff that are just looking for things. This is probably the most inefficient way of doing it. We also have other types of detection. AWS managed services, or for whatever cloud provider you use. And I'm trying to, all of this is cloud agnostic, even though I do represent AWS. Managed services, I'm going to talk a little bit more about that as well. If you have a SIM tool with some sort of threat intelligence, aka grep tool to find things, they might tell you that something is going on as well. Or if you look at Cloud Shell and parse those out and use machine learning, if you're using AWS, check out Athena. It's one of the best tools ever to find things in Cloud Shell. Could be billing alarms. Why do we suddenly have a 10x increase in our bill in our APAC region, or in our LATAM region, or even in the US East data center that we never use? And now suddenly that is bigger than the other ones. Well, again, do you normally run Bitcoin mining? AWS Outreach. And there is an order of these in how less you want this to happen. AWS Outreach. When we send an abuse alert to you, or when we send a notice that something is not right, we're not doing it just to be polite. You might want to check into that. If you get the last one, like a cease and desist, yeah, that's something to pay attention to. But the lower you get here, the more severe something has happened. Absolutely last one, your customers are calling you and asking why their information is out there. You do not want to have that happen. If we look at, for example, managed services, first thing I always ask is, what is a security service? If you look at our marketing or websites, you have a category called security services, for example. The traditional ones, we have guard duty, inspector, Macy, secret manager, whatever it could be. And those are the traditional AWS security services. But we also have other services. We have Lambda, step functions, Cloud Shell events, parameter store. All of these are security services or services that you use as security services. It's really, really important that you don't get hung up on the name or start classifying services. If it can help you with security, use it. And I've actually seen customers where they simply don't use a service because they don't classify it as a security service. Lambda, for example. Lambda is the best security incident response person you could ever have. It's absolutely awesome. It never complains. You can wake up at 3 a.m. and just do a thing. Same thing with step functions or parameter store. Parameter store is a free way of storing secure URLs, for example, for endpoints where you want to send out alerts. So going back to that again, to see where these fit in. And like I said, there's a number of different services that you can use, and I'm not going to sort of just plug services, but if you look at that from an AWS perspective, and not expect everyone to read the text because it's really small. But we do have services to map into identify. We have map services under protect, detect, automate, respond, investigate. This is a automation loop. It should be cyclical. It should be something that you do all the time, even back to recover. If you look a little bit more into the identify, we have a traditional one, CloudWatch for logs, CloudTrail. How many people use GuardDuty or looked at it a little bit? One. Yeah, if you're running on AWS, you definitely should look at GuardDuty as a heads up. It's one of those where it will most likely provide a lot of information. It will provide a lot of things that you should look into, a lot of logs and alerts. They're most likely there for a reason. So if you do get alerts from it, it's worth checking out. Anything from suspicious activity to we found malware on you based on network traffic. We found malware on it, or Bitcoin mining, any kind of cryptocurrency. But it also detects things like bad user behavior. So for example, one alert is that we saw an admin use credentials from an unknown location. Might not be a threat, might not be a security incident, might not be malicious activity, but it's bad behavior, or it could be bad behavior. If you suddenly start accessing your environment from a hotel room, or from vacation on that hotel laptop, or unsecure Wi-Fi, whatever it could be, it's an easy way to detect bad behavior or unwanted behavior. There's also other ones like VPC flow logs. If you're running containers, they're really good because they will give you a lot of information where all that traffic is going. There is a lot of information, so definitely want to have a tool to parse all that, all those logs. Again, Athena, really good for parsing out. Elasticsearch, whatever it is that you want to use. We also have on the protection services. So we have IAM, access management, anything from that to our web app firewall, systems managers, Shield, a lot of different services. I'm not going to go through them. Check it out. Same thing with detection, ability to find things like inspector to be able to go into a host and look for all the CVE vulnerabilities and see how they map against the CVE database and your instances to make sure that you've hardened it properly or that you at least patched and updated it. And if you need to patch it, SSM. Response services, Systems Manager, CloudWatch. If you haven't looked into Systems Manager, again, from a security perspective, it is absolutely awesome. The ability to run remote commands on an instance without even using SSH credentials and SSH keys is phenomenal. And the second thing is that you get a full access log in CloudTrail for everything you do. So if you need to run command from an IR perspective, you automatically get your evidence files generated for you in CloudTrail. This is an important thing. How many people have seen or heard about the shared responsibility model? Couple. Okay, if you haven't seen this, I'll show you a quickie on it, but definitely go in and look at it. This is really important because this will actually tell you what you're responsible for. So when you run in a cloud environment, doesn't matter which one, you do get inherently global security and compliance controls. You do get a lot of different controls, control framework, attestations, certifications, whatever it is that we provide as a subset to you. You do not automatically become compliant. That is extremely important to know. This is what we have. This is not what you have. But this is what you can reference when you go to your auditors. So if you need to be PCI, you can reference our PCI certification as well. If you need to be FedRAMP compliant, run FedRAMP compliant, or if you need to be ITAR or have ITAR workloads, you can reference our information. You can get a lot of these yourself through the console and get the attestation report from them. But this is one of the benefits of running at scale. That you get a lot of these and all of you get the same. It doesn't matter if you run $100 a month, you get access to exactly the same compliance reports as anyone else. This is, however, the more important thing. What do we take responsibility for versus what is your responsibility? So the traditional one, we take care of the infrastructure, the physical infrastructure, data centers, fencing around it, making sure that we have electricity, cooling, all those items. We take care of our edge locations, data centers. Yes, we do have data centers. We also take care of our foundation services, so compute resources, network, all the underlying infrastructure. You, however, are responsible for anything running on top of that. One simple way of looking at it is that if you can configure access and control of it, it's your responsibility. If you can configure who can access a resource, you are responsible for configuring who can access that resource. We will not do that for you. We have services that provide information for you, like GuardDuty, Trusted Advisor, a lot of different open source tooling that will tell you if you've done it or not, but we will not do it for you. This changes a little bit when we go into the container services, because now we're actually running some resources for you. So if you run, for example, EKS, and you run Kubernetes, we actually do take responsibility for example, an ECS as well, like for the scheduler. We take care of some of the nodes and the control plane of the EKS system. The way we will handle the patching, we will take care of all the maintenance of those resources. You are, however, responsible for the worker nodes. You're responsible for anything running on that. You're responsible for the actual containers. That does not change. Same thing with the managed services we have to provide information about it, like GuardDuty. We will provide information about it, but you're responsible for taking action on it. So one thing we hear sometimes is like, well, I only run containers. I don't have to deal with any other infrastructure. Even when you're running, for example, containers, there is still infrastructure around it. Just because you only run EKS doesn't mean that you don't have the other stuff. You have an internet gateway, internet access. You have VPCs that need to be configured. You have access controls that need to be configured. For EKS, for example, we take care of the control plane, so the control plane node and database, but you have to take care of the rest. You have to take care of the worker nodes, the VPC, so the network, the virtual private network. You have to take care of the security group to allow access between the nodes to the nodes. All that is your responsibility. You also have to take care of operating systems. You have to patch, harden, maintain, update. So just because you're running a managed service doesn't mean that you sort of skip out on the responsibility piece. This is just an example of the shared responsibility model with EKS and all the stuff that you're responsible for. Anything from IAM authentication to what else can I say? Operating system, patching, VPC, encryption, super important. Your customer data, you're always responsible for your customer data and your own data. And this is just one way to map the shared responsibility model to the different services. So what else can you do? Well, think big, think integration. So for container, for example, here are a couple of things that we see. Container image corruption, someone added something to your image. Vulnerabilities in your platform, CV vulnerabilities, whatever. One really common thing, use of dependencies that could be exploited. There's a lot of people out there that just link to public repos and link to public references where they don't actually bring them back. This applies to open source as well. I'm a huge open source proponent. I write a lot of open source tools and I release it out there. But open source is one of those where just because you can see the source code doesn't mean that you shouldn't go through it. You shouldn't validate it. You should check it out first. Verify that it's running exactly what you think it is. Download it. If you're not allowed to use open source, learn from it, because it will provide a lot of information. Containers are not hardened, same way as other servers. Very common because a lot of people think that, well, I'm running Kubernetes, so I don't have to worry about the underlying operating systems. You absolutely do. You need to patch it, maintain it. If you don't have a tool for it, we have managed services for it. If you want to run your own tool, absolutely do so. If you want to have just a army building factory and just revamp everything, I have customers that automatically, as soon as a new security vulnerability comes out, they automatically re-roll their whole infrastructure. They don't patch, they just re-roll everything and build new instances on the fly. Same thing with CVE, like use Inspector. If you find something, automatically patch or rebuild. It's whatever fits for you. And in a lot of cases, you've already done this before. Even if you're running on an on-prem environment, you most likely have done this. Just use the same tools if you can. In a lot of cases, you don't have to reinvent the wheel. Second thing is on the integration point. Good example. Does your container network access map to the security groups? So when you know which containers can talk to each other and where they can talk to outside, does that map exactly to your security group configuration? One thing that we'll often talk about is that the application flow is what decides how your security group should be configured. Your application flow should never be able to take any other path. That also means that you should harden it that way. So for example, if you have a web fleet, there's no reason in most cases where a web server should be able to talk to the other web server. That should be hardened and isolated from each other. They have no reason to talk to each other, unless you have a specific use case, of course, but then only allow for that specific port. Don't allow everything. And if you're running containers, make sure that they map, because they should be the same. Same thing, have you integrated, for example, secret manager and parameter store? So now our container services, managed services, have full support for secret managers, so you can actually store secrets that you use in containers. You can use store in secret manager or in parameter store. The difference between secret manager and parameter store: secret manager is if you need to use actually manage secrets or key rotation, database rotation, other type of password rotation. Parameter store is a way to securely store parameters, but it could be a URL, it could be a password, whatever it is, and both of them are 100% IAM integrated. It's just different types of system depending on the use case. When you detect something, are you actually locking and isolating that instance? Are you integrating with autoscaling? Autoscaling is awesome from a security perspective, because if you need to take something out of commission, if that's part of an autoscaling group, it will self-heal. Even if you're using a single server, so if you don't have a full cluster, if you're just one server, you can still use an autoscaling group. And if you take that out of commission, it's going to re-roll itself and self-heal. There are some items where you cannot, for example, assign EIP directly to, I think it's EIP, directly to an autoscaling instance, but there are ways around that. But you can use these to your benefits. Same thing as your business units use these services, you should be using them from a security perspective. Forensics process. Like, what's the forensics process for containers for you guys? Memory capture is a good example. I have one of my hobbies, as I said, is open source. One of my re:Invent sessions, I had a friend of mine from Mozilla who actually just released a tool for memory capture using SSM, where you just issue the SSM command and it will do a full memory capture of the user space memory within like a couple of seconds. And then 2 seconds later, you have a full memory map of that memory snapshot. And that's available as open source today. And it's super easy to use in your IR scenarios. It's called SSM Acquire if you want to look it up. You look up SEC 403 on YouTube. And then integrate containers with AWS controls. Anything that you can script, you can actually integrate with AWS controls. It doesn't have to have native integration. I can, for example, make a script from an old tool that tries to tag myself. Even if I don't have permission for it, I can now see that tag information, and I can actually take action on it. So I can integrate old school tool with full CloudWatch events and Lambda functions to automate my incident response by just issuing a single command. Or if you're running detective services like GuardDuty, like, can you isolate IAM credentials? If you get an alert saying that we found your credentials on GitHub, what do? This leads us into automation. And the thing is, humans are awesome, unless you want consistent results. And yes, I'm quoting myself. That is one of the key reasons why you want to do automation. Automation is consistent. It's consistent bad if you write a bad script. So if you do something wrong, you can do something wrong super fast and really efficient. And it's really easy to nuke yourself if you're not good at it. If you, for example, say that anytime I see this event, I want to isolate this instance. If you do it in a bad way, now you isolate all your instances. So always test, of course. But the thing with automation is that when you wake up at 3 a.m., like, how much data and API do you actually need to detect and isolate that instance? Like, will you be aware of that at 3 a.m.? And to write, of course, a report on whatever happened to it. One thing that we often forget about automation and reactive responses is that it doesn't have to be reactive auto remediation. It takes a really mature organization to do full automation and full auto remediation. That is a end goal for many companies. But what you can do is that you can flip it from reactive to proactive. So for example, when you wake up at 3 a.m., and 3 a.m. is always a crisis, especially if you have kids. But you can take that script and say that anytime I see this event, I want to kick off a step function that will do anything from use Athena to do log parsing for that username, that uses another process to capture from a VPC flow logs, from an SSM to capture instance information, from getting the latest inspector data. Get all of those, pull it back into state management, if you use, for example, step functions. Wait until you have all that information. Push it out through a simple web UI that is locked, of course, for that forensic environment. And then when you wake up at 3 a.m., you already have all that information. You just saved yourself like 2 hours of log gathering. And then you can, of course, go full auto and just say that if I get from guard duty, I'm just going to kick off a CloudWatch event and lock it down. And this works for containers as well. You don't have to run native EC2 instances. You can do this for containers as well. Just integrate them with the control plane. So what's the worst that can happen? Well, never implement auto remediation without doing a threat versus risk analysis. AKA, if this goes wrong, what will happen? If the case is, well, I'm going to isolate all my instances, and in the best case, I maybe prevent Bitcoin mining. Okay, they're not even. But in some cases, it is like, what if all my data bleeds out to the internet versus we have a service outage, which is going to cost you more, your company versus a little bit of outage. Couple of takeaways before I get kicked off. Understand the shared responsibility model. Super important. Especially when you run managed services, especially when you run things like managed containers, EKS, ECS. Understand what is your responsibility. Managed services can offload, but it also provides additional metadata and additional data when you do forensics, when you do security research, when you just want to know what you have. We recently launched Security Hub. Check it out. It's a really good way to find out what you have in your environment and how it meets against the best practices. It compares with the CIS benchmark now. There's also an open source tool available for that to do a AWS CIS benchmark tool to check out how you measure against the CIS benchmark. Harden your infrastructure. If you run on Amazon Linux 2, if you run on whatever OS, make sure you harden before you start running it. How you do it, up to you. If you want to run SSM, or if you want to run your completely own build process, awesome. Have a structured approach, and this is going to be a lot of talks later today, I think, about different ways to build your container services and build your actual containers, and do things like validate the results, validate the launch files, validate configurations. It's really easy to say that just use a Git, and every time someone checks in a new configuration, run a validation process on it to see, are you using unencrypted ports? Are you doing bad mistakes? And then if they do, just rip it out. Send it somewhere else. Update your runbooks. This is something we talk a lot about, but we see very few. One of my pre-event sessions was around forensics on serverless. And it is super critical. It is important to have runbooks. It is an understatement to say that you don't need them. Always have runbooks. Make sure that you update them for AWS, whatever cloud provider you have. And if you're running containers, make sure that your runbooks talk about containers. A lot of people that sit in an on-call environment have no idea what that is. So make sure you always have them up to date. If you don't have runbooks today, Google it. There's a ton of open source runbooks available today. That is like the key item takeaway. Make sure your runbooks talk about what you're actually running. Other than that, it's supposed to say thank you there. Other than that, thank you so much. If you have any questions or want to chat, I'm here for a while. Feel free to grab me and talk about it, whatever you want. Otherwise, thank you.